Another more sophisticated way to expand the notation is like this. 8 times 8 is in the 10 millions column, so we would have to multiply 8 times 10 million. Plus 2, which is in the millions column, we would have to multiply 2 times 1 million. There isn't any number in the hundred thousands column, so we can skip that. 5 is in the 10,000s column, so it would be 5 times 10,000. Our 7 is in the thousands column. The 4 is in the hundreds column. 3 is in the tens column. And our last number, 9, which is in the ones column. That is expanded notation shown in an upper elementary situation. This is a more sophisticated way to show expanded notation, but it's possible to miss a 0 here along the way and throw your whole problem off. There is another even more sophisticated way that mathematicians talk to each other with place value. Let me show that to you now. You must admit that with a number as long as some of the ones that I've been showing you, there can be some confusion when we're using so many zeros on the ends of numbers when we expand the notation. Mathematicians have another way to talk to each other to avoid the confusion of having a misplaced 0. Our number system is based on 10, which really means that in any one given column, the ones column, the tens column, whichever column that I have here, there are only numerals of 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 that can hold a column. Each column can only hold a single-digit number. If we want to express the number 12, we have to have 1 10 and 2 ones, because 12 could not fit into the ones column alone. It spills over. The 1 is in the tens column, the 2 would be in the ones column. So because our system is based on 10, and we only have those single-digit numerals that can fit into any one given column at any given time, we say that our number system is a base 10. Every time we go to the next column over, it is 10 times as much. So mathematicians have a way of using numbers with exponents on them. The 10 to the 0 power would mean the ones column. If we multiply 10 times 1, we're going to get 10. So that would be the tens column. If we multiply 10 times itself, so 2 tens, or 10 times 10, we would have 100. 10 times 10 times 10, that would be this one, 10 times 10 times 10. 3 tens multiplied together is 1,000. So we have our base 10 keeps on jumping one. For each column that it jumps, we have the next exponent. Here's 10 to the 4th power is 10,000. 10 to the 5th power represents the 100,000s column. 10 to the 6th power, we're now into the millions family. To the 7th power, I have to make a tag for that. I didn't get that one done. Okay, 10 to the 7th power means 10 million. 10 to the 8th power is 100 million, and so forth. We have 10, we can do our 10 to the 9th power, 10th power, and so forth. It goes to infinity. Numbers never stop. They're infinite. So our pattern is the same going forward. 10 to the 0 power, 10 to the 1st, 10 to the 2nd power, 10 to the 3rd power, 4th power, 10 to the 5th power, the 6th power, the 7th power, and each time we jump, we're into another column of the placed value.